Hello, everybody. Welcome to High Voltage Seminar. My name is Koteshwar Rao. I'm an applications engineer in isolations team at TI. The session for today is overview of isolation standards and certifications and what they mean for your high voltage designs. Please feel free to ask questions in the chat box throughout the session, and they'll be responded to. Here is the agenda for the session. We'll start by defining isolation. We'll take a look at what is a digital isolator and how it is used in the system. Understand isolation terminologies, various isolation certification agencies, isolation standards, both component and equipment standards. Understand why digital isolators are certified to equipment standards, and how certified isolators benefit equipment manufacturers' designs. Introduction to isolation. What is isolation? Isolation is a means of transferring data and power between two circuits while preventing hazardous DC or uncontrolled AC transients currents flowing between the two circuits. It is a means of transferring data while protecting against hazardous DC and uncontrolled AC transients. When to use isolation? Isolation is primarily used in three situations. Situation 1, to protect a sensitive low voltage circuit and humans from high voltage circuits and systems. Situation 2 is to reduce or eliminate large ground potential differences in communication systems that are separated by long distance. And the situation 3 is to communicate reliably with the high side components in a high voltage motor drive, inverter application systems, high side switches, and metrology applications. These three are the situations or the application use cases where isolation is needed to achieve these functions. And there's a fourth situation why customers use isolation, and that is to protect against high voltage EMI transients. This can be achieved through either isolators or other protection circuits, but isolators offer the best protection. Okay. Here is a system view of how digital isolators are used in a system. You can see that there's an isolator between DSP and CAN transceiver. This is an isolator to provide ground loop isolation, which minimizes or eliminates the ground potential difference that can happen between two communication nodes. There is isolation between DSP and fan, and also between DSP and a motor, and these are used to drive a high side switch and also block high voltage from the fan or the motor reaching the DSP. The isolation here is for both purposes. And then there is isolator between DSP and ADC. This isolator is to block the EMI noise that is appearing at the input of the ADC. Let's take a look at some of the insulation types. Functional insulation. It is an insulation needed for the correct operation of the equipment. It is typically referred to motor drive applications or high side switches, where isolation is not necessarily used for protection. It is used to enable high side driving or high side switching. Without isolator, you won't be able to achieve it. That's why it's called functional insulation. Basic insulation is insulation that provides basic protection against electric shock. If an application has a 400 volts DC and you use an isolator that is rated for 400 volts, then that insulation is referred as basic insulation. Supplementary insulation is an independent insulation that is applied in addition to the basic insulation. And this is to ensure protection against the electric shock in the event of failure of the basic insulation. It is an additional device. If a system has isolator 1 offering basic insulation and you use isolator 2 to provide another layer of insulation, and that is referred as supplementary insulation. And double insulation is the insulation that comprises both basic and supplementary. If a system has both basic and supplementary insulation, then the system is said to have double insulation. And lastly, reinforced insulation is a single insulation system which provides a degree of protection against the electric shock that is equivalent to double insulation under the conditions specified by the standards. If instead of 2 insulation devices, if we use one isolator that is offering the protection of the 2 insulation devices, and that device is said to be offering reinforced insulation. Let's take a look at some other isolation terminologies. VIOTM is the temporary overvoltage of an isolator that it can withstand for 60 seconds. It is a parameter that defines tolerance against overvoltage, temporary overvoltages on supplies due to load changes and arcing, other things. And this parameter is defined in peak. For example, VIOTM can be said to be as 8,000 volts peak for a device. VISO, the isolation withstand voltage, is an voltage of an isolator that it can tolerate for 60 seconds. And this is defined in RMS or DC. It is a similar term as VIOTM, except the difference is that these both are defined in different units. VIOTM is in peak, VISO is in RMS or DC. And both define the tolerance to a temporary overvoltage conditions. The next parameter is VIORM. This is the maximum repetitive peak voltage that an isolator has to handle continuously for its life. And this parameter is defined in peak. It is a voltage that a device is expected to support throughout its life. And this is defined in peak. VIOWM is the maximum continuous working voltage that an isolator has to handle continuously for its life. And this is defined in RMS or DC. Just like before, the VIORM and VIOWM, they both are similar, just defined in different units, peak and the DC or RMS. If an isolator is used in a system with 400 volts and that is continuously present for entire life of the device, then the device, you would require a device which has a working voltage or a maximum repetitive peak voltage of 400 volts. Okay. The next one is V-surge or V-impulse. V-surge is a maximum peak voltage of a surge waveform that an isolator can withstand. The typical surge waveform has a shape of 1.2 microsecond rise time and 50 microsecond half pulse time. And this is tested in oil. Same test if it is done in air, and if the rating that you achieve is called V impulse. V impulse and V surge can be very similar, but if the package of an isolator is smaller than the ratings of the device, then your V impulse rating can be lower than V surge. And these two parameters represent the direct and indirect lightning strikes that they can withstand. A minimum of 10 kV is required to term a device as reinforced isolation. Creepage is a minimum distance from pins on side 1 to side 2 along the surface of the package. This defines the working voltage that a device can support. Clearance is a minimum distance from pins on side 1 to side 2 through air. And this defines the peak voltages or the surge voltages a system can support. CMTI, common mode transient immunity, is the maximum rate of change of ground potential difference between ground 1 and ground 2 that an isolator can withstand without bit errors. This indicates the robustness of the isolator to ground noise. And this is very important in gate drive applications like motor drive, traction inverter, solar inverter, and others. Let's take a look at the creepage and clearance in a little more detail in a graphical way. The picture on the left shows how creepage distance is measured. It is the shortest distance between the two conductive leads from the left side to the right side measured along the surface. The package surface defines how much creepage you can achieve. Clearance on the right hand is measured through air between the leads on the left side and the leads on the right side. This is the shortest distance between the two leads. It could be measured in a straight line or it could be measured along the surface, but it has to be through air. And in most cases, typically you will see that your clearance measurement is less than creepage because along the surface, there's also air that's present, and that also defines clearance. Based on the package design, clearance can be less than creepage, but it'll never be more than creepage. Now let's take a look at the certification agencies. TI's isolation products are typically certified for combination of these 5 certifications agencies. VDE, it's a German certification agency, and it translates to Electrical Engineering Association. UL is Underwriters Laboratories, is an US-based certification agency. CSA is Canadian Standards Association based in Canada. TUE is a German standards certification agency, and it translates to Association for Technical Inspection. CQC is China Quality Certification, is a certification agency for China. Let's take a look at all these certification agencies in a little more detail. Starting with VDE. VDE is the largest testing agencies in Europe, and they are headquartered in Frankfurt, Germany. VDE has worked very closely with IEC to develop an international component level standard, IEC 60747-17, that is applicable for digital isolators, both capacitive and magnetic isolators. IEC is an international electrotechnical commission, is a non-governmental international standards organization that prepares and publishes international standards for all electrical, electronic, and related technologies. The IEC 60747-17 is one of the key standards that applies for digital isolators. And VDE has worked with IEC to develop this standard. The websites for VDE and IEC are listed out here. VDE certifications. TI's ISO products are typically VDE certified for the following certifications. And this includes both component and equipment standards. Component standard for capacitor magnetic couplers is DIN EN IEC 60747-17. Equipment standards that VDE certifies are DIN EN 61010-1, which is a standard for test and measurement equipment. DIN EN 62368-1 is a standard for audio video information technology equipment. These are the standards that our products are typically certified for through VDE. And VDE conducts annual factory inspections at our final test sites. VDE logo is mandatory and is printed on product shipping label. VDE also requires that TI collects quarterly sample data. TI's VDE certification links are provided here. Link for basic as well as link for reinforced. UL stands for Underwriters Laboratories, is a US-based safety certification agency. CUL certifications cover Canada. These are basically the certifications by UL, but for Canada. Further information on UL can be found on ul.com. TI's ISO devices are typically certified for the UL standard, UL 1577, which is a component standard for optical isolators. UL does not have a separate standard for magnetic and capacitive isolators as of today, but the agency allows certification of digital isolators for the UL 1577 standard. UL conducts quarterly factory inspections at our final test sites. UL logo is also mandatory and is also printed on the product shipping label. UL certificates for ISO devices, you can find them on TI.com. CSA is a Canadian Standards Association. It provides certifications and services for both Canadian and international standards. TI's isolation products are typically certified for the following certificates: IEC 62368-1 and the CSA 62368-1, the international version and the Canadian version for the audio, video, and IT equipment. The IEC 61010-1 and the CSA 61010-1 is for the test and measurement equipment. The IEC is the international version and CSA is the Canadian version. And then IEC 60601-1 and CSA 60601-1 are for the medical equipment. CSA, being a certification agency, certifies for the international as well as the Canadian variants of the same standards. CSA conducts quarterly factory inspections at the final sites. Their logo is also mandatory and it is printed on the shipping label. And you can find the certificates on TI.com. TUV is a German-based certification agency. TUV SUD America is a subsidiary of TUV SUD AG and provides the same services locally in the US. And TI typically gets the following certificates through TUV SUD America. The EN UL CSA 62368-1. This is the same audio, video, and IT equipment standard. EN is an European version, UL is an American version, CSA is a Canadian version, and TUV certifies TI products for these variants of the standard. Similarly, the EN UL CSA 61010-1 is a standard for test and measurement equipment, and the European, American, and Canadian version of the standard TUV certifies our devices for. TUV performs biannual factory inspections at the final sites. The logo is optional, and it isn't printed on the product shipping label due to space limitations. You can find the TUV certificates for ISO devices on the TI.com website. And the last certification agency, CQC, stands for China Quality Certification. TI's isolation products are typically certified for the following certificate through CQC. GB 4943.1.2022. It is a similar standard as the IEC 62368-1 that applies for audio, video, and IT equipment. All the testings is done for altitudes up to 5,000 meters and in a tropical climate. CQC also conducts annual factory inspection and requires annual verification test. CQC logo is also mandatory and is printed on the product shipping label. In addition to paying for regular factory inspection fees, TI pays annual certification maintenance fee. CQC certificates for ISO devices are also available on TI.com. Those are the 5 certification agencies we get our isolation devices certified for. Now let's take a look at the standards that we referred to in the previous slides. And among the standards, there are component standards, then there are equipment standards. The IEC 60747-17 is a component standard. As mentioned earlier, we certify our isolation components to the IEC 60747-17 through VDE certification agency. The IEC 60747-17 is the first international component standard for digital isolators and was released in year 2020. Previously, the IEC standard was only available for optocouplers, and we were only certifying for the VDE standard that was German-based and not an international standard. Now, VDE also certifies for the international version of the digital isolation standards, which is the IEC 60747-17. VDE issues 2 kinds of certificates, the German variant of the international standard and the European variant of the international standard. And the German variant is labeled DIN EN IEC 60747-17, while the European variant is named EN IEC 60747-17. Since these are the component level standards, digital isolators must comply with all the required clauses of the standard in order to be certified to the standard. The IEC 60747-17 requires some of the tests to be done on the devices, and those are classified into 3 types: routine tests, sample tests, and type tests. Routine tests are the non-destructive production tests that 100% of the devices are subjected to in the production line. It includes testing for isolation performance, apparent charge magnitude, and parametric performance. All the devices that you receive go through the routine test. Sample test. It is a destructive quarterly test conducted on a small sample set. This includes visual inspection, resistance to soldering heat, apparent charge magnitude, parametric performance test, isolation resistance, external creepage and clearance. The sample test is quarterly conducted, and these are the tests that are done as part of the sample test. All of this data is submitted to VDE quarterly. And then there is type test, which is a destructive qualification test conducted by the certification agency to grant certification to the standard. This means it is the first test that the device will have to go through to get certification to the standard. It includes a much larger set of tests covering various aspects of the device. Type test is the test required for certifying, while the sample test and the routine tests are required to maintain the certificate throughout. That's about the IEC 60747. Now, let's take a look at the UL 1577, another component standard. This is a component standard for optic couplers, but digital isolators are allowed to be certified according to the standard. And UL rates the device either for single or double protection level. Double protection rating is defined for isolators in some unique audio, video, and similar applications bridging reinforced insulation. We typically do not see requirement for double protection, and hence we only qualify our devices for single protection level. Single protection rating. Single protection isolators require the following 3 tests. Dielectric voltage withstand test is a standard isolation test. Overload test is a test of the isolation device under overload conditions. It is loaded with 50% more load than what it is rated for and tested. Limited thermal aging test is a thermal test where the device is subjected to a specific time for a specific temperature. Double protection rating requires the below 2 tests in addition to the ones listed above. And these 2 tests include life test, which is a variant of thermal aging test with different timings, different temperatures. Discharge test is a high voltage test that applies 20 kV to the isolators. That was about the UL 1577 component standard. Now let's take a look at the equipment standards. IEC 62368-1 is the equipment safety standard for audio, video, information, and communication tech industry. For certification, the isolation devices are subjected to dielectric test before and after thermal cycling. And the dielectric tests are performed at 60% more stress than the rated isolation voltage of the device when the DTI of the device is less than 0.4 millimeters. DTI is distance through insulation, which is the thickness of the isolation barrier. Creepage and clearance are also considered in ratings evaluation. Production test for 1 second is required at the rated voltage. Certification agency that can issue UL, CS, EN, the European versions of IEC 62368-1 based on regional needs. So UL, CSA, and the European versions of the certification for this standard can be issued by the certification agencies. IEC 61010-1 is the safety standard for electrical equipment for measurement, control, and laboratories. This is the test and laboratory industry. For certification, isolation devices are subject to dielectric test, and the reinforced rating for the isolators with DTI less than 0.4 millimeters is accepted per class 14.1A based on the IEC 62368-1 reinforced rating. It is similar to the requirement of the 62368-1, where 60% higher voltage is stressed on the device than it is rated for. Creepage and clearance are considered in the ratings evaluation. Certification agencies can issue the UL, CS, and EN versions of the IEC. Basically, the IEC international standard can be tested by the certification agencies for the regional, for the regions for US, Canada, and Europe. IEC 60601-1. This is a safety standard for medical electrical equipment. For certification, isolation devices have to be subjected to defibrillation-proof test, which is applying 5,000 volts DC across the isolation device. And this test is followed by 4,000 volts RMS dielectric test. Standard used different terminology for defining isolation, and two means of patient protection designation typically refers to reinforced insulation. Thermal cycling is also required for this IEC standard. Dielectric tests are also performed at 60% more than the rated voltage when the device has a DTI of less than 0.4 millimeters. The standard also requires that the devices to pass 4-hour operating test with maximum temperature and currents, followed by a dielectric test. Creepage and clearance are considered in the ratings evaluation. For example, here is a table that defines the clearance and the creepage for given operating and working voltages. How are digital isolators certified to equipment standards? The digital isolators are components, and there are component standards already available that the isolator can be certified for. Which TI isolators are certified for as well, and why they need to be certified to equipment standards additionally. Can a tiny semiconductor component be certified to all the classes of a complex equipment standard? An equipment standard will have definition for various aspects of the equipment, while a tiny semiconductor device only has some test up from the standard relevant to it, and hence it cannot be tested for all the classes in the standard. It is only tested for the relevant classes in the standard. Here's a list of such clauses that apply to isolators from the equipment standards. Creepage, clearance, distance insulation, thermal cycling, humidity, dielectric test after thermal cycling, after temperature test, defibrillation test, and material classification. All these are the tests from these end equipment standards that apply to isolators, and the isolators are only tested for these specific tests, and hence they cannot be tested for all the tests in the standard. How certified isolators facilitate equipment manufacturers' high voltage designs. When equipment manufacturers select certified components for their high voltage designs, they save time, money, and the engineering effort. If they do not select certified components, then they would have to test various isolation components in their equipment um, to get the certification. And since the devices, the components are not certified already, they may or may not pass the certification requirements, which could cost time, money, and engineering effort. Only the component manufacturers have the complex construction details of the insulation barrier that is required by the certification agencies. Such information the equipment manufacturers might not be able to provide to the certification agencies, while component manufacturers will have all the access to the information and will be able to provide this to the certification agencies. Certifying a single component typically costs tens of thousands of dollars. This means it's a big cost for the equipment manufacturer to individually certify all the components in their equipment. Engineering effort required to certify another manufacturer's component is also daunting. Finally, the certified components reduce the risk of insulation failure once designed into the product. Hence, it is important to have the isolators that are already certified for the equipment standards so that they do not have to go through all this process by themselves. That concludes the presentation on the topic, and thank you again for joining this session, and also for the great questions. We will see you again tomorrow for the high voltage seminar. Thank you.